There it is.
Yep, sure. So, can you hear me?
Yes, we can
Okay,
hear you.
good. So, I partnered than a previous meeting or some that I hopefully. Um, so I will focus on the benefits and talk about maybe savings, I mean, cost savings. Um, and I will walk you through um, code examples that I haven't, at least in the series that we are having now, I haven't talked in details on the code itself of, let's say, CP78. So I'm going to restart. Does it work? Oh, cool.
Yeah,
Now it works.
good. Works.
Yeah. So side by side, like that's what I was working on. Like me, Igor, and Adam. So he's working on some other stuff right now. So there are three of us now. Um, So what we've done, Igor was working on improvements to the tooling, making the like build tool more usable. So some cleanups were done, and on my side, I was doing benchmarks and analyzing the costs of this new VM. And Adam is working on more like internal, like ramp up stuff, like error passing between WAS and the host. So that's more like not really visible to the end users, but very important to organize this. So, okay. So, this is, oh, wait, what did I do? So, it took me a while to run the same benchmarks on the new VM. There were some differences. I don't want to dive into the details because it's boring for most of you, and I think that was also the feedback I've got. So the idea is that the main difference and the main change is that new WASM VM I mean, it is ahead of time compiler, which means it will go through the WASM opcodes and emit uh, native instruction for a given CPU architecture. So it doesn't have the overhead of the interpreter, right? So each time interpreter executes new opcode, you have to crank the main loop of the like get the next instruction and do some work. So the there were yeah. So it's what the results I got from the benchmark were just different, right? I couldn't really apply the same methodology as you can see on the right side. We have opcode multipliers, which could capture some overhead of the like gas metering and other modifications we do to the WAS. And on the other side, you have new costs, which are more predictable, I would say. Let's say you can see the cycles. On, yeah, so on the right side, you have actually cycles times the multiplier, right? So on the new engine side, I had to choose different multiplier. That the multiplier is fixed, right? To fit into the desired computation time and the limit. So in most of the opcodes, you can see it's much lower in terms of cycles. Cycles look much more closer to the CPU manual. So that was a good observation to see, and that it behaves much more predictable in terms of cycle count, right? And and then you have to still multiply, like you have to still go from cycles to the gas cost. So for that, there is a fixed scaling factor. I couldn't do really like multiplier based, like multiplier on like on the right side, just because from my observations, turns out when I benchmarking the opcodes with overhead, such as gas metering, turns out it is predictable and observable on the benchmark. Although when I apply this overhead multiplier to the costing model, turns out in the real world wasn't like compute intensive. Turns out the measured and calculated overhead is too much of a cost, and that lowers the computation time by factor of, I think, 10, I observed. So when I went to the scaling factor, like, which is more like a fixed factor, to go from non-overhead benchmarked cycles and multipliers, and then validated it with real world WASM, then I could derive another scaling factor to saturate the computation. So it will fit within the time bounds that as desired. And the reason is that the overhead on the ahead of time compiler of gas metering is not that noticeable in the real world. Means it is just faster, right? And at least that was my conclusion from those tests. So I think it's
We have.
okay. Yeah,
I
we
think
can
we
do
have a
now.
question. Okay.
Let's go. Why not? So go ahead, Andre.
Um, so you mean that the overhead of calculating the gas cost at runtime was too high with a multiplier, right?
Yes, that's correct. Even though I could really see even though in the benchmarks I could really see the overhead, like the increased time of the gas metering. When I applied those costs, like if I calculated the multipliers based on the benchmarked overhead, turns out on the real world, it's just too expensive. And in specific example, I had like some test compute intensive wasm that normally would run 7 seconds, right? Without testing the scaling factors. And with the calculated overhead, it was gas limiting after 1 second. So clearly the multiplier was just too high. So yeah. And also I can talk a little bit of details on how the gas metering works on the new engine. Is basically it's internal to the WASM. It's not external. And the difference is that in external mode, as in the current we have in the 1x, 1x to 2x, is that each time we accumulated gas cost, we call host function. And in the new model, we don't call into the host, which is like switching the context between like VM to the host and back. It is expensive, but in the new engine, in the new gas metering, we do have internal. That means each time we accumulated opcodes, we just increase a value that is local to the program, basically, right? So it's not that noticeable because we don't switch the context back and forth, and it's much faster, right? And it also still translated into the native code. So basically when you I guess analyze the compiled code, it's maybe a couple of instructions, like maybe some memory or even register. I haven't dig deeper into the emitted assembly code, but I can imagine it is just much less overhead overall. And yeah. And also it works by blocks. So if you have a lot of computation and you basically want to accumulate the cost, not every instruction, but every couple of instructions, right? Before you change blocks or in the loop, right?
Yeah. So there's no marshalling costs, right? But
Yes.
how do you prevent someone jailbreaking within the VM and essentially cheating the gas count? Is it like a separate?
Yes.
Are you loading up like 2 VMs and like how are you managing that?
So the answer is the code that you give us. Let's say there's any code you give us, we process it still, right? When we load the WASM, we run run a program that will instrument it with the extra instructions. So in the case of WASM, in the new engine, it's as I said, it's an internal gas metering. So the metering code will add a new global variable, and then how do you prevent?
Yeah. So sure. So
Mhm.
basically, but it's still subject to
Mhm.
potential injection hacks, right? So
Yes, it is, but the difference is that you would have to predict it ahead of time. What is the index of the new global variable? But you can't, because
okay.
when you load
Got it,
the WASM, all the indexes are validated. So you basically cannot do that.
Okay. So it's not a stable address. Essentially,
Mhm.
it's arbitrary, and so you wouldn't be
So,
able to necessarily predict it.
exactly. So in other words, even if you predicted the index, you still can't use it because it's not valid WASM, right? If you will give me code, I will add a new global, then you can't reference it from your code because you don't know it and it's not valid code if you still try to do that, right? So it's like just impossible, right? It's not valid WASM if you try to do that, and it's rejected very early.
Do you check to see when the index is assigned? It would be an unassigned index, like.
It's just it's like referencing missing variable, right? You can, it's not correct code basically if you
Yeah.
try to reference it. And from top of my memory, I think we had some security issue some time ago, like maybe 2 years ago or something like that, where it was actually, we had to actually fix that. I don't remember the details, but
Right.
I think found it. Yeah, it's
That's
very,
basically what I'm coming at,
yeah.
is like it's a similar vector, right?
Yes, it's very similar vector, and it is protected at the like systemic level, right? It's the parser is another thing is that the parser in the WASMer is like I would say officially branded bytecode alliance parser. That is not like in-house parser that we had to patch it a couple of times in terms of parity code we used to have. I mean, we still have, but we forked it, right? But in the new one, it's like bulletproof parser, basically like endorsed by the bytecode alliance, and there's like lots of effort put into it. So you basically can't parse that WASM if you try to cheat.
Got it. Cool. Thanks.
So I selected a bunch of opcodes, and I can see across the board it's cheaper. I guess still work in progress. Like there's smart more tests we have to put into this, so we can still probably tweak the scaling factor. But overall, the results are promising. And in terms of like very expensive opcodes, it's the savings are significant. And what can I say more? I think that's from the compute side, right? So let's go next. Quick example. CP18 installation. It was 0.2 Casper compared to 600 of. I took it from mainnet from I think Shibu token installation. The like earliest deploy for Shibu. So it is. I think it looks a lot, but we still have to, I think, tweak, let's say, storage, because I raised some topic for our economists, and in terms of like gas cost, because for like gas per byte figure, like does it still make sense? Isn't it too high? Could we maybe capture it differently? But this is with the gas costs, gas per byte copied over from the V1 chain spec, and then also host function costs were also tweaked. Lowered. So when we have time or some resources in future, we might still want to apply the same. Like since the amount of host functions in the new engine is not that high compared to like V1 engine, we might attempt to benchmark execution time of the host function to derive like real cycle count per host function. But I don't think we have like resources to do this for now. I think that the values I picked are reasonable for now, but I think it's still work in progress. So it might increase, but like as you can see, the room is, we have lots of room to improve the cost. Like we might increased, then it still will be reasonable. And also, I can imagine on the right side, most of that cost was just the storage costs. Still, the overhead of values written in the old engine is significant. I can imagine. Also, the weights and the costs on the host function on the right side might also be significant contributor to the high costs. So yeah, it's still working in progress, but we have room for improvement. Still, like even if it's, let's say, to Casper, it's still good savings. Same for transferring. Transferring is actually also an interesting example because on the left side you can see it is slightly more expensive than install. It comes from the fact that we are using some containers inside, like collections for data for storing the balances. So you can imagine like overwriting two values at least, and also reading and writing contract state. So not much compute, but more storage cost. Same on the right side, it's much more simpler, right? And same thing. You have some overload of dictionary on the right side, and I can imagine also not much compute, even though there is a lot of overhead, like getting the named arguments and name keys and stuff, so on. So I've got there is also CP78, but I will talk about just the code itself. CP78 is huge, even after porting it from the old one. So it wasn't easy to like quickly do like apple to apple comparison. So that's work in progress to determine the differences. But I'm still hopeful that it might be still cheaper in the current settings. Okay, let's go side by side. That will be interesting to dive deep into the code to see the benefits of the new engine. Um,
In the meantime, do we have any questions so far, maybe? Okay, feel free to post your questions anytime in the chat.
Yeah. So John, the 2.0 binary contains the prototype of this, but it's turned off in the chain spec. And so on a test network, you can turn it on and play around with it. And that's basically the move forward. And then our current plan is we're aiming to get the new VM into a production grade state in 2.1 and continue like through the patch releases for 2.0 to add further refinement. So basically with the releases we're putting out on a 2.x, the new VM is a available piece of machinery, and then on like testnet, mainnet, etc., it's turned off. But in a test network, you can turn it on, and then you can experiment, write your own contracts, also give feedback. And then also another key point is to date, Mihal and Igor have been mostly working on it alone. But as we've wrapped up the other deliverables, the core engineering team is now starting to focus and put cycles onto it as well. So we're going to be augmenting, coming up to speed with where Mihal's at and augmenting his efforts. And of course, it's also open source, so if people want to contribute to it, they're welcome to do so.
Okay. Yeah. Trying to show enough. Okay, let's go Okay, so on the left side, there's like existing code. It's not. I do a lot of updates currently on this repo, but I think it's relatively up to date. I haven't updated it actually, but I think it's mostly the same anyway. So let's look at the constructor thing. So on the right side, I have this new NFT contract that is like proof of concept part of this functionality. And let's dive into the constructor. And first of all, we have like NFT contract state defined through basically it's a inheritance through composition, right? You embed another struct onto it. So the plan was to implement a trait for NFT. So like basically you can implement NFT contract for your contract just by using traits. But it's in like still work in progress state, right? So the state is in order to do that, we had to understand the data model on the old and current code. So let's say arguments like getName args. So for each getName arg, we added a new argument to the constructor. For each of the stuff that we get name key for or put name key, we extracted it into the state as an attribute. So let me try to find a couple of data items. I stopped the rationalizer because of the red underlining. There's still some issues with the macros, at least in the separate repo. If you have separate repo with the code referencing the code we've written, sometimes it's failing to parse. Where's the date? Types, I guess types. Oh yeah, so this is the basically named keys. So like, I mean, the equivalent on the left side would be named keys for each of those. So let's say get name key, get key, right, installer. So like in this case, like ownership. So yeah, so this is the difference. Like if from 1x, 2x, like name keys, it was the data model when you create new URLs with the data, but on the right side, you create structs that can contain all the data you want. And basically it will be written as a one block into the global state rather than multiple URLs per data attribute you have. So that the benefit of this approach is that you can just reference the data basically as a legitimate like a idiomatic Rust, just self-state installer rather than get name key installer, parse it from CL value into what you want and then compare it. So it looks a bit, I think, readable. Where's the top of the slide? Okay, and so yeah, let's jump back into the constructor. So basically, in the constructor, you have to construct new instance of the contract object. And then under the hood, the macro will basically write the state of the contract into a global state. And what you return here is the contract state struct, basically. So there is some special macro for this that will implement like how to serialize it, how to deserialize it, and some extra code. And yeah. So let's say collection name. Where's the collection name? Oh yeah. So basically, yeah, like I said, we went through all the arguments or named keys, and then just put a list of arguments like a function. Yeah. So less error handling. I think. I mean, I will not explain it. I think it's just shorter. What else? ACL. So all the minting mode stuff. It's also here. I mean, okay, we don't validate actually in the proof of concept, but it's there, right? I think it's validated. Yeah, when you change variables, also it's validated. Where is it ending? So basically, this is so the new entry point, aka constructor, is equivalent to the init function here on the left side, and then let's say set variables. So this is more like so let's say set variables on the left side looks like this on the right side, right? That's how you define the same equivalent code. And here, I think it's interesting example on terms of like ergonomics of storage. When you get the argument, you have to type it. That's also like error prone. Like you can shoot yourself in the foot if you make a mistake here. Like if you've written, let's say, integer, but you want to read a bool, then you will get the serialization issues. But on the right side, it's kind of workaround. I mean, it's not really workaround, but it's harder to do this because the macro is taking care of the type safety, right? You are reading the NFT state object, and then you deserialize NFT state object. But when you execute the code, you have NFT state and all the types of the attributes in there. So you can't have. I mean, you can, but you have to really try. But you will be saved from foot guns, at least in the serialization. So on the other side, when you want to write the data, at least it's the reading, right? So on the right side, you don't need to read it because the macro already reads the data for you. So but if you want to write data, allow minting. So this is the equivalent code from the left side and the right side. So what it is doing is that it will modify the deserialized object under the that is deserialized under the hood before the entry point is started. And when you modify it, since you have mute self, then the macro can, after executing the set variables entry point, the macro can take the state object and then write it back to the global state for you. So you don't need to worry about that, right? So you can just set the Boolean, right, value, and then the other side of the code will just take that object and put it in the global state. So no need for explicit writing of data. You can just modify the data and not worry about it. So what else from the set variables? Wait lists, events. It's not yet updated for the native messages. I think we are working on that still on the left side and in current development, right? On the RIP on the left side, but on the right side, I implemented a port of messages API from 2.0. So I will show later. I will try to quickly show the CP18, which is updated because it's in the main repo, so it's always up to date with the development and how to emit events in the new engine. Let's say ACLs, minting, right? So this is very similar. It's managing storage and validation support. So that's also an interesting aspect of this. We realize also in some ways you don't, like, if you want to migrate from old code to the new engine, you don't need to always do it exactly the same way. Let's say here, we realized that on the left side, let's say it was a JSON passed as a string and validated, and then some data was extracted from it. So there were some, of course, reasons, like valid reasons to do that. But on the right side, we realized, like, how about we don't pass JSON, like introduce new serialization mechanisms that also are expensive on the WASM. How about we would just pass the metadata as an object that is clearly defined, like in the Rust, and then just rely on the serialization method to just like deal with this at the arguments level. So you can just pass the metadata as an argument, and then the object will be just serialized for you, and you can save on the like like computation for doing JSON. And then also schema is helpful because if you define some like complex objects such as NFT metadata, you will benefit from the schema because the SDK, the tooling we will provide will describe that object for you. So if you want to consume this data, you should be able to, if you will consume the schema of this contract, you will be able to properly deserialize the object or serialize metadata object to pass it. So that should solve some issues, some troubles as well, and make it more optimized, hopefully. Burn. What's more interesting about it? Oh yeah, maybe wasn't told properly yet, but the error handling. I think it's visible, but I mean maybe it's not visible, but I want to like maybe bring it to attention. On the right side, we can all just deal with results. So I basically in the new VM, anything that is serializable, you can return it. So it is convenient then to just return a result and then just leverage like question mark operator and so on, and simplify the error handling for you. Oh yeah, good point, Andrzej. This is separately, but it's much more like a proof of concept. So maybe some of the comments will be also copied over that are maybe not matching the new functionality. But yeah, when we have something more concrete to show, like say, for people to deploy their own tokens on the DevNet, perhaps we can make that code that you can consume more understandable or readable. Yeah, so on the error handling, basically, as you can see on the left side, we develop some custom utilities to deal with the like missing values or error handling. So you have to provide the variance here, right? So you can't really use question mark operator unless you will add more extra layers of abstraction. But it's more like straight to the point, right? Like more iterative structural coding. But on the right side, it's all taken care of for you. So you can return anything that is serializable and make it an output of the contract. So when you return something, you can just pass data, and the macro handles the serialization of the result object. And that makes it possible to use a question mark operator, like return OK or error, and simplified some of the error handling. But what else? There is some logic mostly copied over, adjusted wherever it's possible, but continue.
I think we
Yep.
have 10 minutes left. There is
Oh,
one
yeah.
more question in the chat. Maybe you could take a look at this. It's from XY.
Oh, okay. I didn't notice that. Learning smart contract experience, but can you give an estimation of the real world impact? It's not to call transfer image fast, but it will. Oh yeah. So the real world impact. So I showed some like initial results from the measured outputs and the gas costs, and I think the real world impact, if you have, let's say, faster VM, like all in all, if you have faster VM that can execute more codes in same period of time, so you can also say that you can maybe execute more transfers or more, I don't know, approvals or what like you can compute more code in the same period of time, right? So that would be the real world impact after all. That ability to increase the limits of the chain, like change the WASM lanes to provide more computation if we are switched over to the new VM. So I guess what metrics would be interested in probably is the TPS metric that we could probably, let's say, tweak it from 25 WASM lane into something higher, of course, pending testing. Maybe I'm not sure if I answered the question XY. I think that's what I would say about it. You will have more, say, 10 times more interactions per in the block, or in theory, right? Depends on the configuration. Faster means more computation.
Okay. XY reacts with a like, so it seems like you have answered the question.
Right. I mean, hopefully, we can talk on Telegram later, but I think that's least intuitive way of looking at the bit of execution is that just more computation. So before, let's say 7 minutes, I will jump over to the CP18. CP18 contract and the messages API. So it was something I think screenshotted. I was still working on it at the time. I took the screenshot on the last meeting, but it's implemented already. So if you want to emit a message from the contract, you have to define the message struct that will define the attributes on this. Under the hood and the SSE, you will see Casper as a string, right? And then payload would be bytes of this, serialized bytes of this. So on the contract side, we will have there is a and the trait. Okay. And yeah, so when you would say approve, you can emit a struct object. So you define, like you just create an object and emit it. And under the hood, the host will take the name of that on this message struct and then serialize the content of it, then use the appropriate mechanics under the hood, set the block summary and stuff like that, just like explained the CP some time ago. And you should be able to see this on the SSE after it's executed. And same for transfer, right? So there's some notes. I think it's maybe not that useful to have this valuable because like serialization can fail or some in theory when you use the host function under the hood, it could still fail, but I think, yeah, maybe it doesn't need to be this way. We can as well panic under the hood for such cases. So in this case, it's much more complex object here. Transfer has optional from, and the reason is it's taken from the OpenZeppelin ERC20 example where they have one event for transfers and mints. So in terms of ERC20, they're using like all zeros for minting, but in our case, we can just use optional. So when you transfer, you have sender, then you will put some. When you mint tokens, you will emit transfer with a none. So yeah, that's the API. What's the cost of emitting these events? It is the answer is complicated to some extent because we have when you emit an event, we touch at least 4 different keys in the storage, and also we have different weights on the on the host function. So I think the cost would be that, at least in the terms of like gas per byte, I can tell you right away. It's the length of the topic, which is, let's say, transfer the message payload, which will be serialized bytes of this, and a serialized value of the like marker per block, which is just two values. I think U64 and U64. Was it? Block time, which is U32, I think, and 64. So there is some overhead of the system that you pay for, and also you will pay for the host function execution. So something I'm yeah. While doing this, I haven't put like metrics into the slide because I think yesterday I realized maybe it is confusing, right? Maybe we could like put the accommodate the storage costs in the chart of the host function. Let's say, for example, I was looking at also like Ethereum. You have this store opcode which you pay for in 20,000 gas per 32 bytes written. So you can derive a gas per byte metric, but it is at the opcode level. So in terms of like Casper, it will be host function that will write data. So I was thinking maybe it will be easier.
So that might. So I think that's orthogonal, right?
Mhm.
So what you're talking about could be pursued. However,
Mhm.
the message emitting specifically generates a hash,
Right. Right.
and that's what gets written. So the inputs for the
Mhm.
hash
All right.
are what you're partially paying
Oh,
for,
right.
and then we hash it and we store that. So
Yes.
the storage cost is based upon the actual value stored,
Mhm.
which is smaller than the inputs, right?
Yes, that's true. I forgot
Yeah.
about that. Yes, that's
So
the storage.
I wouldn't rush to over optimize
Mhm.
that, right?
Mhm.
Because also because the topic is user the label of the topic is user defined up to a maximum width. If a individual contract, is very, like just X, Y, Z, it does not have verbose naming around that. Well, then you're going to have lower overall costs. And if you have more descriptive topic names, then you're going to have a higher cost. You get charged for that because it's more
Mhm.
bytes, right? So
Yeah.
I don't know that you would be able to. I mean, you could of course abstract and just hand wave it, but then you would have to err on the side of overage, which would prevent people that were, looking to shave costs. It would prevent them from doing that. So I wouldn't
Yep.
rush to optimize that.
Yeah, that's a fair point. Also yeah, I think that's a fair point. It would be convenient probably to like in terms of like configuration, but in the end, I think it's on the other side. You could say let's keep the gas per byte metric, but let's say adjust the cost function weights, so you wouldn't pay twice for something, right? So, um, yeah.
I don't think you do in this case though, right? So in this case, the specific case of there's a host function to receive an emitted message, which has parts, right? There's the topic, there's the message itself, there's some other sort of ambient variables like block time and so forth.
Mhm.
There's the issuer of it. There's where you're at within the call stack, which is also relevant for ordering. So there's an ordering, right? There's a total number. So it's a multi-vectored input, and then that then gets dispatched. Some of it gets dispatched to the metadata, which then allows it to get picked up by the SSE feed, right? And then the other part of it actually gets, the hash of that as a checksum gets put to global state under a specific address. So it's there's some irreducible complexity there, and because there's also it's not all systemically defined. There's user defined topic names and messages, like they're that's not under the system's control, and they are of variable length. So you would need necessarily to represent that in the cost. You would be able to just hand wave that away, right?
Yeah.
Today,
Makes sense.
we honor all of the brave American and Indian military service members who work together to safeguard our freedom.
What is that?
We stand proudly in defense of liberty, and we are committed to protecting civilians from the threat of radical Islamic terrorism.
Okay, just remove them.
A Zoom bomber.
Yeah, thank you for a quick break, but I think overall we are done. So, any more questions?
Let me take a look at our chat. I think we covered all of the ones that are in chat. So I think well,
Andre's comment.
okay, let me.
Here's another one.
Okay, I need to change the setting.
Yeah.
So-
Like moderated would be probably better.
Yeah. So I think it's useful to recap. I mean, the main thing is the new VM work that has been progressing has come along pretty well. I think quite well, considering that it's essentially a two-man show at this point. The goal is to lower the bar for entry, to make it simpler for people to implement contracts, and to reduce overall costs, increase efficiency. And so I believe that there's still a couple places where some refinement needs to occur, but generally we're on track for our objectives. And then what we're really hoping is that sort of people that are interested in what comes next will be starting to focus on this. We've been talking about potentially having an environment where we explicitly switch this on so that people can play with it without having to host their own test network or spin up a local network, which I think we're almost certainly going to do.
Shut up, Randy. Shut up, Randy. Shut up.
So anyway, so basically, as we go through the next few weeks and get 2.0 to mainnet, and more attention spins over to 2.1 and this VM, we really hope the community gets engaged and plays around with it and gives us not just technical feedback, but also like feel, like whether it works. It works. It should work, but does it also feel good? Does it feel like an improvement? Do you feel like you're able to get more done more quickly? So
like a feedback or validation from the community is very important for me, for us, for future of this, right?
And some of that feedback from the last call has been incorporated here. So as you can see, it's very welcome, and we are trying to do our best here.
And just one more piece of feedback that was posted by Andre in the chat is more extensive comments in the code examples, which is something we pick up.
So, yes. So I wanted to like circle back to this. So the idea I have in mind is to provide some kind of ready-to-use pieces of code to develop contracts. Let's say you should be able to import CP18 and have most of the logic implemented. That will be like a kind of, let's call it a standard library for contracts for Casper. That will be like used best practices and commented well, so it's easy to understand. So you may not want to use it or import it. You can maybe still copy it and still understand it. So that would be, I think, useful for people.
Great. All right, we are well over time, and I don't want to invite more Zoom bombers or Google Meet bombers. I guess we'll have to adjust the settings for the next one. But this was great.
Yeah, thank you very much, Michał. Thanks, Michael, and thanks, Ed, for your contributions.
Thank you.
Thanks, Mia. Thanks everyone for joining.
And see you on the next one. Bye bye.